All right, continuing our discussion on exponential functions and their graphs. This particular video is going to talk about exponential instead of growth, decay, which basically means we're going to have something decreasing, and this is when the b is going to be less than 1, but greater than 0 yet. B can never be negative, and we are referring to b as this value right here, the base of this equation. So as we did before, we would look at the most obvious 3 points. We're still going to have 0, 1, because anything to the 0 power is 1. When x is 1, 1/3 to the 1 would be 1/3. So I'm going to have the point 1, 1/3 out right there. And then if x is negative 1, remember it flips it. So 1/3 of the negative 1 would be a positive 3. And I'd have the point negative 1, 3. All right, so you can basically see here that this is the reflection of the 3 to the x graph. All right, this graph would look like this. It would have a domain of all reals. Your range would be y is greater than 0. And then as we change things, let's say I've got an x plus 2 here. That would move each of these points 2 to the left. So I would have these particular points. And the graph would look like this, with the same domain and the same range. If I had, let's say, a minus 4 out here, that would move these points down 4. And so I would have these particular points. And the graph would look like this, with a domain of all reals and y being greater than a negative 4. And then if there was a number out in front, let's say I've got a positive 2 out here, that is going to double the y coordinates. So now doubling these, I've got negative 1, and we're going to talk about this in our next slide here, so we can break this down step by step here. But this would be just moving something that has exponential decay, which again is when the b value is between 0 and 1. All right, this next equation, again, we would start out with getting our basic points. We've got 2/3 to the x. So those points are now going to be 0, 1 again. I'd have 1 2/3, and then negative 1, and again a negative 1 power flips it, so it'd be negative 1 3/2, which is 1.5. And so I've got this particular graph. Those are my 3 starting points here. All right, now we've got some movements here. This first movement here, because we're going to do the power first, so this is going to move it to the right 2. Then we are going to do the multiplication, so that's going to vertically stretch it and flip it. And then we're going to do our addition and subtraction, so this is going to move everything up 4. So taking this step by step, first of all, this red movement, I'm going to move everything right 2. That would also, in my table, I could just add 2 to all of these x coordinates. And those would be my new points. Okay, so I'm going to have the negative 1 3/2. Moved right to the 2 is going to be 1 3/2. 0, 1 is going to be 2 1. Positive 1 2/3 would be 3 2/3. So you can see these points are just moved to the right 2. Now this negative 2 out in front is going to multiply your y's by a negative 2. So if I multiply each of these by a negative 2, here the 2's cancel, you'd have a negative 3. This would be a -2. And then you'd have a -4/3, which is like a -1 1/3. So then I'm going to have 1 -3. I'd have 2 -2. I'd have 3 -4/3. So you can see it now flips it. And this graph would have a domain of all reals. Y is less than 0. And then finally, we would do the addition of subtraction, which is going to add 4, move everything up 4. On the table, if I add 4 to all these, I'd have 1, +2, and then adding 4 to a -1 1/3 would be 2 2/3. So now moving these points up, that would be at 1 1, I'd be at 2 -2, or 2 2, sorry. And then I would be at 3 2 2/3. This graph is going to look like this. And we're going to get closer and closer to 4. You see it's increasing. Your range would be all reals. Your domain would be y is less than, because flip down less than 4.